Okay, now we move to next part, analysis of the empirical survival distributions. So last time we learned on the new notation, which is observed proportion surviving to time t, whereas we denote it as st. Actually, st it is the estimator for st. So we use the proportion. So this is the formula for st, number of survivors at time t, divide with n. So we can denote it as nt over n. So number of survivors specific at time t, and over n is the number of sample size. So this is recall for the last class. So you can read by yourself. So this both st equal to nt over n, number of survivors at time t, both are follows binomial model. Why? Because we are looking for whether the individual is die or survive. So, or we can say not survive. So it follows binomial distribution. Therefore, we can find the expected value for number of survivors at time t using binomial distribution by time n time st, and the variance is n times st times ft. Okay, so in binomial distribution, this one represents succeed, this one represents fail. Still remember, because ft is actually 1 minus st, so succeed and fail. Since our st follows the binomial distribution, so when we find the expected value of estimator of st, we will get the st back. So st is the estimator, right? So the expected value of estimator, so we will get the st. And then the variance for st also follows the binomial distribution. And finally, we will get this. So succeed times fail over n. Okay. Thus, we have estimated for variance st actually is equal to ft. This is estimate st minus ft over n. So the estimate is st 1 minus st minus ft over n. Okay, don't worry, don't get confused. So we try example 3. Okay, example 3. Okay, example 3 says that suppose it is known that survival distribution to which our example in 2 is actually subject to uniform on 0, 15. Okay, uniform. Remember uniform distribution? So uniform distribution, we have 2 parameters. It represents A and B. So in survival distribution, B we call it as omega, since this is the max age, maximum of age, and this is the minimum of age. So age always from 0, the newborn, until omega. So the general formula for uniform distribution, we denoted it as A and B. But for our survival model, we use omega instead of B. So what is the variance of random variable S6 for A? So we have to find survival function for at t equal to 6 using uniform distribution. How? So still remember how to find ST for uniform distribution. So for uniform distribution, actually it is for, recall back De Moivre's law, our good friend De Moivre's law. De Moivre's law actually follows uniform distribution. So how to find ST for De Moivre's law? So ST is equal to omega minus T over omega. So FT actually is 1 minus omega minus T over omega, and we will get T over omega. So S6 is equal to omega is 15, T is 6 over omega equal to 0.6. And F6, T over omega, we get 0.4. Or FT is equal to 1 minus ST. So we can use either one. And then after we get the S6, so variance S6 equal to S6 times the failure over N. So S6 is 0.6 times 0.4 over 8. So N is 8 equal to 0.03. So for A. Did A follow uniform distribution? And B, if the uniform distribution assumption is not made, how would we estimate variance ST? Okay, we go back to notes. I forgot to highlight to you. Okay, this one. Since the distribution of ST is unknown, so if the distribution is unknown, we can only approximate or estimate the value of ST in place of ST to obtain the value of variance ST. So we have to use this formula if the distribution is unknown. So for B, to find variance S6 with no distribution, or the distribution is unknown, so we follow the formula given before in the previous notes before the example. So ST is equal to NT over N, number of survivors at time T over the sample size. So NT, if you go back to our example 2, okay, S6, no S6. So S6 here equal to number of survivors at time 6 over number of sample. So here there are 4 people already die. So total we have 8. So 4 over 8. Right? So S6. So 4 people already died. Total we have 8. So 8 minus 4 is 4. So the number of survivors at time 6 is 4. And N is number of sample size is 8. So we got 0.5. So F6 is 1 minus 0.5. So equal to 0.5 as well. So the variance is equal to 0.5 times 0.5 over N is 8. If you compare the value for variance, it is just slightly difference between uniform distribution and if we do not follow any specific distribution. So this is ST times FT over N. Okay, same as this one. Okay, so just it's easy. So I have a good news for you. Please do this exercise. So please submit to me via WhatsApp before tomorrow at 6 p.m. And then you just snap your answers and WhatsApp me personally, not in the WhatsApp group. WhatsApp me personally, because it is considered as your attendance for today and tomorrow class. Okay, so group times of death. We move to group time of death, and then we have large cohort group where number of sample size greater than or equal to 30, and with fixed intervals. It can be day, week, or year. Okay. Let N equal to initial size of the cohort under study. So we denote it as N naught. So for complete data, all N study units are observed to fail. So as long as the subjects are still survive, so the observation still going on. So each of N failure falls into one of the K intervals where K is set large enough so that survival to time K is impossible. So K intervals, if we draw the timeline, so T equal to 0, T equal to 1, 2, until K intervals. Okay, so let dt, random variable of the number of death in the interval t to t plus 1 for 0 to tk minus and 0 before interval for interval t from 0 to k minus 1. Okay, because here it becomes dk minus 1 to 1, isn't it? So 2k. So from t to t1, meaning that t to t plus 1. So it's one interval for dt. Because no number at the back here, so we it assume as only one interval. Okay. NT is random variable of survivors. Okay. NT random variable of number of survivors at T. NT is realized value of NT in an actual study. So this is random variable. This is in an actual study. And then dt also. dt also the random value number of death at t, and dt is realized value of dt in an actual study. So that's the difference between big NT and small NT, and as well as the big DT and small DT. So so NT plus 1 actually NT minus DT, or we can say it as NT plus 1 equal to NT minus DT, and DT equal to NT minus NT plus 1. Okay, QT, probability of death from T to T plus 1, remember? So PT is actually 1 minus QT. It is complementary survival probability. And ST is unconditional probability. Then, since it is unconditional probability, ST times QT is equal to this conditional probability. So remember this notation. Okay, our favorite. So let me show you one timeline. Okay, so let's say T equal to 0, T equal to 10, T equal to 11. So our constant is only for for the probability of death between 10 and 11. So it is Q 10 to 11, 1 in front. So we assume that here still, until here is still survive. So ST is equal to make it this unconditional, so you have to divide with the conditional probability with the QT. So this one, if you write down this case, it becomes STT is so Q0 to 10. Sorry, here is 10. So S10 here is from 0 to 10 still survive. We just constant on 10 to 11. Probability of death over Q10 to 10 to 11. So we will get the unconditional probability of survival. Okay, the distribution of NT and DT. So for this part, it is just want to show you the derivation from here, how we get this one. So you just ignore this. What you need to know only this. So NT is binomial with parameters N and ST. So ST, QT, we just play around with the equation. The mean and the variance for both, the mean and the variance, using binomial as well, since NT and DT follows the binomial. So the actual studies also follow the binomials. So if you notice that just now we use FT and ST, now it just we just replace the ST and FT using the probability of death QT and probability of survive PT. That is the relationship between this distribution for NT and DT in terms of probability. Okay, thank you guys. We stop here.